Hi guys, in this video we're going to take a look at how to find the greatest common factor of a polynomial, or the GCF. Really, a greatest common factor is exactly what it sounds like. It is the biggest factor that a set of terms all have in common. So to do that, here in this first example, we're going to start by listing the factors of each term, and then identifying what the biggest thing is that they have in common. So you can see here we have the polynomial. We have 5x cubed plus 25x squared plus 45x. So we're looking to find the greatest common factor between those three terms. So I'm going to start there with that 5x cubed. And we're going to list out the factors of 5x cubed. Remember, factors are really those prime numbers that you multiply in order to get your term. So to get 5x cubed, well, 5 is a prime number, right? The only factors of 5 are 1 and 5. So we have 1 times 5 to get that coefficient of 5. And x cubed, the factors of x cubed are x times x times x. Okay, so those would be the factors of 5x cubed. If I multiply 1 times 5 times x times x times x, I get 5x to the third power. For 25x squared, our factors would be 1 times 5 times 5 times x times x. For 45x, you might have to think a little bit harder on this one. You could think of it as 9 times 5, right? But that 9 is not prime. That 9 can actually be broken down further. So we could think of it as 3 times 3. So 1 times 5 times 3 times 3, right? 5 times 3 is 15, times 3 is 45. And really that 3 times 3, you could think of that as that 9 broken down. We know that 45 is equal to 9 times 5, and 9 breaks down into 3 times 3. So our prime factors here would be 1 times 5 times 3 times 3, and here we just have that 1x. So now we have the factors of each of those three terms. We want to go through and we want to find the greatest common factor. So we want to see what these terms all have in common. Well, they all have a 1 times a 5, right? We all have that starting 5 as our factor. And beyond that, the only other thing that all three terms have in common is 1x. They all have at least 1x. So here the greatest common factor is going to be 1 times 5, or really that's just 5. And they all have that x. So 5x is the greatest common factor. Each of these terms could be divided by 5x, and you would have a whole number as your answer. So that's what our greatest common factor would be. All right. Let's go ahead and try one more here just to make sure we've really got the hang of that. So the greatest common factor of 3x to the 4th minus 9x squared minus 12x. So we're just listing out those factors. For 3x to the 4th, that's just going to be 1 times 3 times 4 x's. For negative 9x squared, that's going to be a 1 times 3, and then you need a negative 3 also. You can put that negative anywhere you want. If you want to put it on the 1, you can, or you can put it on one of the 3's. So 1 times 3 times negative 3, and then 2 x's. And then we have a negative 12x. So for negative 12, I could start by saying, well, we've got a negative, so I'm going to have a negative 1. And then when you think of your factors of 12, you might think 6 and 2, or you might think of 3 and 4. So if we say 3 times 4, well, that 4 is not prime. So instead of listing a 4, we're going to break that down into its factors. The factors of 4 would be 2 and 2. So instead of 4, we're going to write that as 2 times 2, so we can have those prime factors, and then x. All right, so now when we go through and look for the greatest common factor, they all have that 3, right? And I really shouldn't have even circled those ones because you can see that one of them is negative, so those really aren't quite the same thing here. So we just have really that 3 in common and 1x. So our greatest common factor here would be 3x. All right, we are going to use this to start factoring polynomials now. Now that we know how to find the greatest common factor, we can start doing some factoring of polynomials. And really, when we're factoring out, this is very similar to division, right? The opposite of factoring is multiplying. So the opposite of factoring out, like we said, is multiplying. We've already learned how to multiply polynomials. Now we're going to go the other way and we're going to factor something out or kind of divide everything by its GCF. So when we do that, our first step is finding the GCF, what we just learned how to do. So it's asking us to find the factored form of 4x to the 5th power minus 24x cubed plus 8x. So to start with, we're doing exactly what we did before. We're looking for the factors of each term so that we can identify the GCF. So here we have 4x to the 5th. That is really 2 times 2 times 5x's. 24x cubed, negative 24x cubed is really negative 1. And then I would think of this as 3 times 8. 24 is the same as 3 times 8. So times 3 times 8. But instead of 8, we need to break 8 down into its factors. And 8 is really the same as 2 times 2 times 2, right? 2 times 2 is 4, times 2 again is 8. So I'm breaking that 8 down into its factors, and we have 3 x's here. And the last one, that 8x, I'm going to do up here. We just said that 8, its factors are 2 times 2 times 2 times x. So now when I look for that GCF, we can see that each of these has 2 2's, right? We have 2 2's in each place, and we also have at least one x. So the biggest thing that I can take out is 2 times 2, or 4, right? 2 times 2 is 4, x. So if I'm going to factor out a 4x, we're really dividing each term in the polynomial by 4x. So our third step here really is taking that entire polynomial, 4x to the 5th, minus 24x cubed plus 8x. And we are factoring it out. This is kind of like, you could also think of it as the opposite of the distributive property, like pulling out that GCF from each term. And so when we do that, like I said, to get our factored answer, we have to take each of these and divide it by that GCF. Okay, and so we're not really getting rid of that 4x. We're more pulling it out front like we would if we were undoing the distributive properties. I'm going to go ahead and over here, this is where I'm going to write my final answer. So I went ahead and said, okay, I'm pulling that 4x out in front of the parentheses like if I was undoing distribution. And what's left inside is going to be whatever I get from dividing each of these terms by that GCF. Well, 4x to the 5th divided by 4x is just x to the 4th power, right? Those 4's divide to make 1, and x to the 5th divided by x is x to the 4th. We keep our base and subtract those exponents. Remember, this is like an exponent of 1 if there's no exponent written. Then if we do negative 24x cubed divided by 4x, that leaves me with minus 6x squared, right? 24 divided by 4 is 6. X cubed divided by x is x squared. And lastly, 8x divided by 4x is 2, right? 8 divided by 4 is 2. X divided by x is 1. So really we just have a 2 left there. So this is the final factored form then of this polynomial. 4x times the quantity, x to the fourth minus 6x squared plus 2. So really what we've done there is we've kind of factored out or pulled out the GCF from each of those terms. We now have this written in a factored form. If we wanted to check our answer, we could always redistribute. If we wanted to check, we could redistribute this 4x to everything inside the parentheses. And that would hopefully give us our original expression. And so if you wanted to check your answer, that's how you would do so. All right. I'm going to go ahead and leave this one right here for you guys to practice. If you want to practice it right now, you can go ahead and pause the video and try this problem. If you'd rather try it at the end after you've watched the entire video, that's fine too. But if you're going to do it now, go ahead, let's pause and come back when you're ready. The last thing we're going to look at here is kind of an application of these factoring problems. So it says that a helicopter landing pad or helipad is sometimes marked with a circle inscribed in a square to make it visible from the air. It's asking us to find the area of the shaded region of the helipad and write our answer in factored form. So you can see we've got this square landing pad with an inscribed circle inside, okay? And it's asking us to find the area of kind of this darker shaded region between the circle and the square. And so to find that area, hopefully we know we would have to find the area of the square, and subtract the area of the circle, right? To find just kind of those corners there that are shaded in. Well, we know that the area of a square is equal to the side length times itself, right? So this is equal to 2x times 2x, or you could also write it as 2x squared. And the area of a circle is pi times the radius squared. So here our radius is x, so we would write that as pi x squared. All right, so then if I go ahead and kind of simplify this expression here, we know that 2x times 2x is going to be 4x squared minus, we still have this pi x squared. And if our last step is writing our answer in factored form, that means we need to find the greatest common factor between our two terms, between 4x squared and pi x squared. And I don't think we really even need to list out our factors here. I think that you guys kind of know your factors of 4 are 2 and 2. And pi is a prime number. The only factors of pi are 1 and pi. So the only thing that these two have in common then is those x squareds. So the GCF is going to have to be x squared. That's the only thing that they have in common. So that's what I'm factoring out. So I can go ahead and kind of pull that out as if I was undoing that distribution. And if I were to divide each term, we know that 4x squared divided by x squared would leave me with just a 4. And pi x squared divided by x squared would leave me with just that minus pi. So my final factored form then would be x squared times the quantity 4 minus pi. All right, the last thing that I would like you guys to do is try this problem. Super, super similar to the one we just did. It says a circle with radius 3x. I'll even draw you a picture here. Circle with a radius of 3x is inscribed inside a square with a side length of 6x. So you've got your square, and it tells you that side length is 6x, and you are writing an expression in factored form to represent the portion of the area of the square that is not included in the area of the circle. So it would be kind of this shaded region on the corners, just like that last problem. So right now, you go ahead and try this problem, and if you have not already, go back and try that problem that we just had up here, this other practice problem. If you haven't done that yet, go back and try those 2 practice problems, and that's all you've got for this video. If you have questions, if you're not sure about something here, please send me a message so that I can help you. I will be online today checking email until 3 o'clock.